Welcome all. Now I am going to discuss question number 45 from the GATE 2021 paper Electrical Engineering. The question is, an 8-pole 50 Hz 3-phase slip-ring induction motor has an effective rotor resistance of 0.08 ohm per phase. Its speed at maximum torque is 650 rpm. The additional resistance per phase that must be inserted in the rotor to achieve maximum torque at start is in ohms. Neglect the magnetizing current and the stator leakage impedance. Consider equivalent circuit parameters referred to the stator. To know the concept of torque produced in an induction motor, audience can go through the given NPTEL video link. Let us discuss the useful information to solve the problem. Slip at the maximum torque is calculated as Ns minus Nt max divided by Ns, whereas Ns is the synchronous speed of the stator, Nt max is the speed of the rotor at maximum torque, and this slip is calculated mechanically. Also, the slip can be calculated with the help of electrical circuit parameters, and it is given by the rotor resistance divided by the standstill rotor reactance. At standstill, slip is equal to 1. So, using this information, let us solve the problem. So, given data. What it is given? Given is number of poles is equal to 8 and the frequency of the supply, it is 50 Hz. Also, the machine is 3-phase slip-ring induction motor, and the rotor resistance of rotor is 0.08 ohms, and speed at maximum torque is equal to 650 rpm. So we need to find out the additional resistance that must be inserted in the rotor. Additional resistance that must be inserted in the rotor we need to find out. So, slip mechanically, how we can find out is Ns minus synchronous speed of the stator minus speed of the rotor at maximum torque divided by synchronous speed. We need to find out the synchronous speed first. Ns is equal to 120 into F by P. That is 120 into frequency of the supply is 50. Number of poles are 8. So, that is 750 rpm. So, we can find out synchronous speed. Just now we found out 750 minus speed at maximum torque is 650 divided by the synchronous speed. If we solve, we will get this one as 0.133. 0.133. This is the mechanical slip. Slip electrically, how we can calculate is rotor resistance divided by the rotor reactance. Resistance of the rotor divided by the reactance of the rotor. And we know that S mechanical is equal to S electrical. slip at mechanical is equal to slip electrical. So 0.133 is equal to rotor resistance. How much it is given? 0.08 ohms divided by the reactance of the rotor. After further simplification, X rotor is equal to 0.6 ohm per phase. So, maximum torque at starting. Maximum torque at starting that induction motor should produce. At starting means we already know that S is equal to 1. S is equal to 1 means R2 plus some additional resistance we need to add in the rotor circuit, that must be equal to the reactance of the rotor. Rotor resistance is 0.08 plus R external is equal to X2 naught. Just now we found out that is 0.6. So R external is 0.52 ohms. So this much of additional resistance we need to add in the rotor circuit so that maximum torque can be produced at the starting. So the additional resistance required is 0.52 ohms. Thank you.